Hello, my dear students, and welcome back. I know, your exams are just around the corner, and this chapter on squares and cubes can feel a little, well, tricky. But you don't need to worry one bit. In today's explainer, we're going to break it all down and make it super simple, super clear, and you know what? We'll even have a little bit of fun with it. So, to get started, let's jump into a really cool story. I want you to imagine a wise and wonderful queen. Her name was Ramanujan. And when she passed away, she left behind a huge fortune of precious stones, ratnas. But she also left a very clever puzzle for her son, Prince Hoisnam. And believe me, this puzzle is the key to understanding this entire chapter. Okay, so picture this. The queen has set up this challenge, right? There are 100 lockers, all lined up in a secret room, and there are 100 people, the prince and 99 of his relatives, all ready to try and solve her puzzle. The rule is simple. Whoever solves it first gets to keep the whole treasure. So what we're going to do is solve it right here, right now, together with the prince. Now, every game has rules, and this one is actually pretty simple, but it's brilliant. Here's how it works. Person number 1 goes along and opens every single locker. Easy. Then person number 2 comes along. They go to every second locker, so locker 2, 4, 6, 8, all the way to 100, and they toggle it. Now, what does toggle mean? It just means they change its state. If a locker is open, they close it, and if it's already closed, they open it up. Then person 3 toggles every third locker, person 4 every fourth, and this goes on and on all the way up to person number 100. And that, my friends, brings us to the big question. The one question that unlocks the entire fortune. After all 100 people have taken their turn, which of these 100 lockers will be left open? Just think about that for a second. So, how in the world do we solve this? Well, the secret isn't really about opening and closing doors. It's about math. Of course it is. The whole solution is hidden in one simple idea. How many times does each locker get touched or toggled? This is our very first clue. Let's look at an example to make it really clear. Let's take locker number 6. Who's going to touch it? Well, person 1, person 2, person 3, and person 6, right? That's 4 people. An even number. So it starts closed, then it goes open, and finally closed. It ends up closed. But now have a look at locker number 9. Who touches this one? Person 1, person 3, and person 9. That's 3 times, an odd number. So it goes open, closed, open. You see? It ends up open. So here is the most important idea. A locker is only toggled by people whose numbers are factors of that locker's number. This means the number of times a locker gets touched is exactly the same as the number of factors its number has. And since only an odd number of toggles leaves a locker open, we just need to find the numbers with an odd number of factors. So the big question is, which numbers have an odd number of factors? This is it. This is the final piece of the puzzle. The big aha moment that Prince Hoisnam had. Are you ready for it? The answer, my dear students, is perfect squares. And what's a perfect square? Oh, it's so simple. It's just a number you get when you multiply an integer by itself. Like 2 times 2 is 4, or 5 times 5 is 25. That's it. Simple, right? And this right here shows you why they're the key. You see, for most numbers, factors come in pairs. Look at 16. You have 1 and 16. 2 and 8, but then there's 4. It's paired with itself. 4 times 4 is 16. Because of this one self-paired factor, perfect squares and only perfect squares end up with an odd number of total factors. And there we have it. The lockers left open at the very end are all the perfect squares between 1 and 100. Prince Hoisnam figured this out, he solved the puzzle, and he won that entire fortune of ratnas. And guess what? Now you've solved it too. See, that fun little puzzle about Prince Hoisnam just taught us the most important property of square numbers. So now let's use that same simple logic to power up for your exams. I promise you, the stuff you actually need to know is just as clear and logical. Okay, here is a super useful trick, especially for your multiple choice questions. Just look at the very last digit of a number. If it ends in a 2, a 3, a 7, or an 8, you can be 100% sure it is not a perfect square. No need to calculate anything. This one little shortcut is going to save you so much time in the exam hall. You know, math is full of these beautiful hidden patterns, and this is one of my absolute favorites. If you add up consecutive odd numbers starting from 1, you will always get a perfect square. The sum of the first 2 odd numbers is 2 squared. The first 3 give you 3 squared. The first 4? 4 squared. Isn't that just so neat? All right, but what about bigger numbers? How can you be totally sure if it's a perfect square or not? Well, the best, most reliable method is prime factorization. It's simple. If you can break down a number's prime factors and split them into 2 absolutely identical groups, then it's a perfect square. So for 324, you can see it breaks down into 2 groups of 2 times 3 times 3, which is 2 groups of 18. And 18 times 18 is 324. So yes, it's a perfect square. Now that we're masters of squares, let's just quickly talk about their cousins, cubes. The idea is almost exactly the same. A cube number, or a perfect cube, is just what you get when you multiply a number by itself 3 times. So 2 cubed, that's 2 with a little 3 on top, is just 2 times 2 times 2, which equals 8. And cubes have their own amazing stories, you know? There's a really famous one about our great Indian mathematician, Srinivasa Ramanujan. A friend of his came to visit him in a taxi, and the taxi's number was 1729. The friend said, "Oh, what a dull number." But Ramanujan immediately said, No, it's a fascinating number. And why? Because it's the smallest number that can be written as the sum of 2 different cubes in 2 different ways. What an absolutely brilliant mind he had. All right, my dear students, we're almost there. Exam time is close, so let's do a super quick, high-energy revision of the most important points from this whole chapter. These are the things you absolutely must remember. Okay, let's lock these in. 4 key things. Number 1, perfect squares are the only numbers with an odd number of factors. Don't forget the lockers. Number 2, use that last digit trick. If a number ends in 2, 3, 7, or 8, it is never a perfect square. Number 3, with prime factors, a perfect square can be split into 2 identical groups. And finally, number 4, for a perfect cube, it's the same idea, but with 3 identical groups. If you remember these 4 points, you are all set. Now, we are not going to end with a simple goodbye. No. Let's end with a fun little challenge to keep your brain buzzing. The puzzle is this. Can you arrange all the numbers from 1 all the way to 17 in one single row so that any 2 numbers that are next to each other add up to a perfect square? Give it a try later. It's a fantastic puzzle. And that's all for today. Just remember, the real key is to understand these ideas, not just memorize them. Keep practicing with these little tricks and puzzles, and I have absolutely no doubt that every single one of you will do wonderfully in your exams. All the very best.